Okay, in this segment, we'll be looking at ways of reducing rational expressions. Simplifying rational expressions or simplifying a fraction is basically reducing the fraction to lowest terms. And so in this section, we're going to look at those rational expressions. How do we simplify them or reduce them to lowest terms? The first step that you have to do is to factor top and bottom. Remember, you can never cross out without factoring. You can never cross out terms. The 2a is a term, the 14 is a term. You can't say, oh, I can cross out the 14 with the 28. 14 goes into 28, I can cross them out. You can never do that. Remember to be very careful because you have to have multiplication across the top, multiplication across the bottom for you to be able to cross out. And if it's not written as multiplication, then you cannot do that. So to write the top and the bottom as multiplication, what we do is factor, because factoring is rewriting a sum as a product. So I take the numerator and factor that. I see that a squared plus 3a minus 28 is a trinomial with leading coefficient 1. So that makes it really easy to factor. So I'm going to factor it to two binomials. The a squared is a times a. 28 is what? 4 times 7. So I'm just going to try 4 times 7 using trial and error over here. And the last term is negative, so my factors will be positive, negative, or negative, positive. But I want the final middle term, the combination of inside, outside, to be 3. So positive 3, so I have to make the 7 positive and the 4 negative. So the most important thing is to make sure you factor correctly, because if you don't factor correctly, you can never get the correct answer. Now, the denominator of this rational expression is a binomial. And to factor a binomial, to factor any polynomial, you need to think of pulling the greatest common factor out first. And this has a common factor of 2. So I pull the 2 as a common factor. I need to multiply it by a to get the 2a and multiply it by plus 7 to get 14. So I factored both of them, numerator, denominator, and now I need to look for common factors, because when you divide a plus 7 by a plus 7, you get 1. When you divide the number by itself, you get 1. So the a plus 7 over a plus 7 is basically a factor of 1. So you reduce that to 1. And so your simplified answer would be a minus 4 times 1 is just a minus 4, and the bottom you have just 2. And that would be your simplified answer. Be careful. You can't cross out this 2. You can't reduce the 2 with the 4, because the 4 is not a factor. It's not multiplied. It's added or subtracted with something else. So this is a term. So this will be your simplified answer. OK, let's take the second example here. Again, I want to reduce or simplify. Remember, step number 1, factor. And trinomial on top, it doesn't seem to have a common factor. So I'm going to use trial and error to factor that. 8y squared, I don't know, I'm just going to try 4y times 2y. And 3, it's going to be 3 times 1. And if the last term is positive and the middle is negative, you know that both signs have to be negative. A negative times a negative will give you the positive last term. And then when you have negatives for inside and outside, notice that the inside is negative 2y, the outside is negative 12y. And so they add up to negative 14y. So this worked out. Now to factor this denominator, it's also a trinomial, and I don't see a common factor here. So I'm just going to use trial and error, or any method that you feel comfortable with. I'm sure that some of you have done the AC method or what's called to be the grouping. That's fine, too. So 2y squared, we're going to break it down to 2y times y. 3, we're going to break it down to 3 times 1. And the outside, so I'm going to have positive, negative, and with the larger one being negative, so the 3 has to be negative, and the 2 has to be positive. So I've got it factored correctly, hopefully. And now you look for similar factors on top and bottom because they're reduced to 1. And that leaves you with what's left, which is 4y minus 1 on top and y plus 1 on the bottom. So that would be the simplified answer for that one. Okay. I'm going to erase this part and do those 2 problems here on top. Okay, so number 3, 20 minus 5x. What I can do, it's a binomial, but I have to remember to pull a common factor out. So I see 5 is a common factor, so when I pull the 5 out, I have 4 minus x. And this denominator is a trinomial with leading coefficient 1. If it factors, it would be easy to factor because the x squared is x times x. 12, I'm going to go with 4 and 3. And I'm going to go with negative 4 and positive 3 to give me that negative 1. But now I want to cross things out that I see they are the same. And I don't know about you, but I don't see anything that's exactly the same to cross it out. You probably would think 4 minus x and x minus 4 are the same, but they're not because, remember, subtraction is not commutative. So if you subtract 6 minus 4, is not the same as 4 minus 6. So those are not the same. But you need at this point to recognize that 4 minus x and x minus 4 are opposites. Because every term of the 4 minus x and x minus 4 has the opposite sign. This is positive 4 on top, negative 4 on the bottom, negative x on top, positive x on the bottom. That means 4 minus x and x minus 4 are opposites. Now think about reducing opposites. Opposites, for taking a simple example, negative 4 over 4, that represents opposites. So what do you get when you divide opposites? Okay, a negative divided by a positive is a negative, and then 4 over 4 is a 1. So whenever you reduce opposites, you get a negative 1. And if you take the 4 minus x, there is a way you can write it to make it look like x minus 4. So what I can do, just to make sure that I see that they're opposites, I can rewrite them as negative x plus 4, use the commutative property to switch them around. And then the negative x plus 4, if you pull negative 1 out, then you're going to have x minus 4, because negative 1 times x is negative x, negative 1 times negative 4 is positive 4 when you distribute. So notice that the 4 minus x is the opposite of x minus 4, because it's the x minus 4 multiplied by negative 1, or you can think of it as having a negative sign attached to it. So if I want to do it the long way, then I would say this is 5 times, instead of 4 minus x, I could say negative 1 times x minus 4. So I just replace the 4 minus x with that, because it's the same, over x plus 3 times x minus 4. And now you see that the x minus 4 is the same. But see, by crossing them out, you're left with negative 1 in your expression. And this negative 1 could be in the numerator or denominator, however you want, because you could have taken x minus 4 and rewrote it as negative 1 times 4 minus x. Then the negative 1 would be in the bottom. It doesn't matter. I usually like to keep my negative 1 in the numerator because it's easily to kind of ignore it if it's in the bottom. It gets more my attention if it's on top. So 5 times negative 1 is negative 5 over x plus 3. That's what I have left. So I reduced an expression that is containing opposites. Well, if you understand this, what you can do next time is look at 4 minus x and x minus 4 And ask yourself if those are opposites by comparing. Every single sign has to be the opposite. You could say, oh, I can cross him out and leave -1 in my numerator because opposites reduce to -1. After you have done it this way and you know how to do it, you understand this. But you need to know that you cross out opposites, but that leaves you with -1 because opposites reduce to -1. And one more example, and I think that deals with opposites as well. So I'm going to erase this part. Okay, so b squared minus a squared. To reduce this, I need to factor b minus a times b plus a. Notice that this is a binomial, no common factor, and so it looks like it's a difference of two squares, and I can factor that to b minus a times b plus a over. I want to factor the bottom, and I'm going to use trial and error here, but there isn't really much trial and error since the leading coefficient is 1. So the a squared is a times a, and then 2b squared is going to be 2b times b. And I'm looking at a +1 coefficient for the middle term. So I'm going to make the 2 positive and the 1 be negative. So I get 2BA as the inside, negative BA as the outside, and that results in positive AB for the middle term. Okay, so do I have similar factors on top and bottom? I have b minus a here. I have a minus b here. They're not the same, but hopefully now we recognize their opposites. Because the b is positive here, negative here, the a is negative here, positive here, so they have totally opposite signs. B plus a and a minus b have no relationship whatsoever. They're not opposites and they're not equal, so we can't really do anything with that. But I can rewrite the b minus a to make it look like a minus b, so I'm just going to do it the long way again. This time, the b minus a, I can write it as negative a minus, the quantity a minus b. And then I still have b plus a on top. And then I have a plus 2b on the bottom times a minus b on the bottom. And you see now a minus b reduces to 1, leaving you with that negative sign on top. It's the same as -1. And the bottom will have a plus 2b. And you could leave your answer like this, or you could distribute a -1 here, take care of that negative sign, so you get negative b minus a over a plus 2b. So either one of those answers is acceptable. Okay, so if you want to do it, let's say if you're doing a calculus class, which you require the algebra skill, but you don't really have to do it the long way because you already understand how that works. What you can do is recognize b minus a and a minus b are opposites, reduce them, leave -1 on top. And that takes you right to here. Because now you have -1 multiplied by b plus a over a plus 2b. So that would be a shortcut you could use as long as you understand the concept behind it, that you can manipulate the b minus a and make it look like negative the quantity a minus b.